Hi there! Welcome to Isabel Explains. If you'd like to see when I post new videos and help other students find my videos faster, SEO stuff, go ahead and hit subscribe and that little notification bell. Alright, in this video I'll be showing you how to solve systems of linear equations by graphing, by using the substitution method, and by using the elimination method. Let's go! First of all, what exactly is a system of linear equations? It's simply two linear equations graphed in the same plane. Now, unless the two lines are parallel, they will touch at some point. This point where they meet we call the solution of the system of equations. Another way to think about it is that you're looking for that one value of x and that one value of y that work for both equations. Note, if the two lines have the same simplified equation, they will touch at every point. Therefore, they will have an infinite amount of solutions, and any x-y pair that works for one equation will work for the other. Now, the most common type of system of equations you will find are those that have only one solution, because they'll meet at only one point. So those are the ones we're focusing on in this video. Let's do one example. Let's suppose that you have the system of equations of y equals 2x plus 4 and y equals x plus 5. Well, the answer to the system is that x is equal to 1 and y equals to 6. Why? Because they meet at the point 1, 6. Now, if I were to substitute 1 here, the answer for y would be 6, and if I substitute 1 here, the answer will be 6 for y. If I were to substitute any other value of x on both of them, the answers for their y would be different. And I encourage you to try that. Now, how do we get to that answer? Well, there are three ways of solving a system of equations: graphing, substitution, and elimination. Depending on how the exercise is being presented to you, you should be able to eventually decide which method is more convenient. However, if used correctly, they will all lead you to the same answer. Let's start with the first method, graphing. Let's suppose that our system of equations is y equals 5x minus 7 and 3x plus 2y equals 12. Well, good thing is that we actually have it written in both ways, the slope-intercept form and the standard form, so we're actually going to see how we graph both of them. So let's start with the first one. We said that a system of equations is literally just having two equations on the same plane, right? So that's exactly what we're going to do, and in order to find out the solution, we're going to find out where those 2 points meet. So let's do it. If I have the y equals 5x minus 7, I have it written in the slope-intercept form, which means that this is the slope and this is the y-intercept. So I'm going to start by graphing the y-intercept first, which is -7. So I'm going to go down here. Go 1, 2, 3, 4, 5, 6, 7. So that's going to be my first point. And then I have that the 5 is the slope, which we can say that it's also 5 over 1, right? Which means that it would be 5 up and 1 to the right because it's the rise over the run. So we're just going to go 5 up, 1, 2, 3, 4, 5, 1 to the right. And then we continue doing the same thing all throughout the graph. And that is what that line would look like. Hopefully yours would be a little more straight, but that's okay. So now we're going to graph the second one. And in order for us to graph an equation in standard form, I prefer to just find the x-intercept and the y-intercept because it's just going to be so much easier. So that's exactly what I'm going to do. We know that in order for us to find out what the x-intercept is, we have to make the y equal to 0. And in order for us to find the y-intercept, we have to make the x equal to 0. So that's exactly what I'm going to do. So let's find the y-intercept first. So if I make the x equal to 0, this goes away. So I have 2y equals 12, which means that y is going to have to be equal to 6. So I'm going to put the y-intercept here, 1, 2, 3, 4, 5, 6. And then we find the x-intercept. So in order for me to find the x-intercept, the y has to be 0. So if this is 0, the whole thing cancels out. 3x equals to 12. That means that the x is going to have to be equal to 4. So I'm just going to write it right here. So 1, 2, 3, 4. And then I can just go ahead and draw a line. Really, in order for you to draw a line, you really only need 2 points. Now, obviously, because our, perception of view is not that great, we usually like to have more points. But in reality, you only need 2 points. If you have a ruler or something like that, you can just go ahead and use that. So let's do it. Bam! And then we have the second line drawn. Now, we said that the solution of the system of equations is where the two lines meet. So let's find out where that point is. That point is right here, which means that the solution to the system is going to be the point 2, 3, which means that the answer is that x is equal to 2 and y is equal to 3. Now, sometimes graphing is not the best method because the coordinate in which they meet can be sometimes hard to determine just by looking at it. So we would have to use one of the other two methods. Let's start by using the substitution. In order to use substitution, one of the equations must have an isolated variable. Meaning, if I have the system 2x plus 3y equals 7 and x minus 2y equals 6, I have to isolate either the x or the y in one of the equations. In this case, it makes sense to isolate the x of the second equation because it already has a coefficient of 1. So let's take advantage of that. So what I'm going to do is I am going to add 2y on both sides. So this will leave me with x is equal to 2y plus 6. Now, instead of having this equation, I have this one. Because we know that in order to find the solution of the system, the value of x on both equations have to be the same, I can just substitute whatever x is equal to on the second equation for the x on the first equation. So I would have this. I would have 2 times 2y plus 6 plus 3y is going to be equal to 7. Now, why do we do that? Well, because now we have only one equation with one variable, in this case y, so now we can solve for y. Let's do it. So the first thing we're going to do is distribute this 2 inside of the parentheses. So we have 4y plus 12 plus 3y is going to be equal to 7. So we combine like terms over here. So we have 4y plus 3y is 7y plus 12 is equal to 7. So I then get rid of the 12, pass it to the other side as subtraction. So I have 7y, cancels out, is going to be equal to -5. And then I have to divide by 7 on both sides. So my answer for y is actually going to be -5 over 7. As you can imagine, this is going to be, if we would have graphed this instead of using the substitution method, it would have been really hard to just pinpoint exactly where in the graph that would be. So that's why the graphing method sometimes is not the best method to solve all of them. Now, how do we find the value of x where these two lines meet? Well, easy. I substitute the y on whichever of the two equations. In this case, I'm going to do it on both equations so you can see it, but eventually you won't have to do both. I recommend you always test it on both at first to make sure that you did the math correctly, but once you're comfortable with your steps, substituting it in only one of them should be enough. My preference would be this one because the x is already isolated, but that's just me. Let's do it. So in this one I have 2x plus 3 times -5 over 7 is equal to 7. So what I'm going to do is multiply the 3 times the -5 over 7. So this is 2x plus -15 over 7 is equal to 7. So what I'm going to do is subtract this to the other side, or technically add it to the other side because it's a negative number. So it's going to be plus 15 over 7. So I'm left with 2x is equal to 7 plus 15 over 7. Now we know that every single number is the same number over 1. So what we're going to do is we're going to find the common denominator for both fractions so we can add them, which is going to be 7. So I have to multiply the top and bottom by 7. So I have 2x is equal to 49 over 7 plus 15 over 7. 49 plus 15 is 64. So we have 2x is equal to 64 over 7. And then we're going to have to divide by 2. So what I'm going to do is actually I'm going to multiply by 1/2 on both sides. It's the exact same thing. So x is just going to be equal to 64 over 14. And then we have to reduce that fraction because we know they're both even. So the greatest common factor is going to be 2. So we're going to divide top and bottom by 2. So I'm going to have x is going to be equal to 32 over 7. Another number that would have been really, really hard to spot on the graph. So let's go ahead and do it for the other one to make sure that we did our steps correctly. So we go ahead and multiply the 2 times negative 5 over 7. That's going to be x equals to negative 10 over 7 plus 6. And then again, this is 6 over 1. So we're going to have to multiply it by 7 on top and bottom to have the greatest common denominator, or just a common denominator. And then this is going to be negative 10 over 7 plus 42 over 7. So this is going to be equal to negative 10 plus 42. This is going to be 32 over 7. So x is going to be 32 over 7. See how we get the exact same answer on both sides. Now, obviously, not all systems that you solve by substitution will look like that. I mean, I could have easily solved the first example by using substitution because actually the y was already isolated, so it would have probably been easier. Check this out. The first exercise that we worked on was y equals 5x minus 7 and 3x plus 2y equals 12. Like I said, the y is already isolated, so literally all I have to do is rewrite whatever this y is into the second y. So I would have this equation as 3x plus 2 times 5x minus 7 equals to 12. So I would just distribute this 2 inside of the parentheses. So we have 3x plus 10x minus 14. Please don't forget the second guy. They always get very sad when you forget. Equals to 12. So I combine like terms. So this is going to be 13x minus 14 equals 12. Add the 14 on both sides. So we have 13x equals to 26. And then if we divide by 13 on both sides, we have that x is going to be equal to 2. And then what I do is I substitute that x back into whichever of the two I want. I'm going to choose the first one because the y is already isolated. So I have that y is going to be equal to 5 times 2 minus 7. 5 times 2 is 10. So 10 minus 7. So y is just going to be equal to 3. Bam! That is the exact same answer we got when we solved it by graphing. So we're always going to get the same answer no matter which method we use. Now let's solve a couple of examples by using the elimination method. I left this one for last because not all systems will be easily solved by this method, but it is good to know just in case the opportunity presents itself to use it. Because when you do use it, it's super easy to solve the system. Let's do the first example. We have x minus 3y equals 7 and 3x plus 3y equals 9. So how does this work? Well, basically you can add or subtract an entire equation from the other equation. But why? Glad you asked. Because it'll eliminate a variable right away, and then we only have one variable to solve for first. In this example, what we're going to do is we're going to add the bottom equation to the top equation. How do we do that? Well, we just add up the like terms. That's all we're going to do. So when I add x plus 3x, I am going to end up with 4x. And when I add negative 3y plus 3y, guess what? That is 0. Because I'm actually eliminating this. That's why it's called the elimination method. So this gets eliminated. And 4x is just going to be equal to 7 plus 9, which is 16. And then we divide by 4 on both sides. And we have that x is just equal to 4. Now, how do we solve for y? Well, the exact same way that we did it before. What we're going to do is we're going to substitute this x back into any of the two equations. So we're just going to choose the first one. So we have 4 minus 3y is equal to 7. So in order for us to leave the y alone, what I'm going to do is subtract 4 on both sides. So I'm left with negative 3y is equal to 7 minus 4 is 3. I divide by negative 3 on both sides, so I'm left with y is equal to negative 1. And that's it. My answer to the system of equation is x equal to 4, y equals negative 1, which means that they meet at the point 4, negative 1. Let's do another example. In this case, we have 6x plus 5y equals 4, and 6x minus 7y equals negative 20. In this case, instead of adding the second equation, what we're going to do is actually subtract it. And how do we do that? By being very, very careful with them pesky negatives. All right? Let's do it. So what I'm going to do is I'm going to place a negative sign in front of it. I'm going to put the whole thing in parentheses so that it helps me remember that the whole thing is being multiplied by negative 1, technically, not just the 6x, okay? So I'm going to rewrite this equation as negative 6x plus 7y is equal to positive 20. And that is what I'm going to be adding to the first equation. So let's do it. I'm going to eliminate this right here so that we don't get confused. So if I have 6x minus 6x, that's going to be 0. And then if I have 5y plus 7y, that's going to be positive 12y. And if I have 4 plus 20, that's going to be equal to 24. So if I divide by 12 on both sides, I get that y is equal to 2. And then again, in order for us to find the other variable, in this case the x, what we're going to do is we're going to substitute the y back into any of the two equations. So let's just do it on the first one. So we have 6x plus 5 times 2, 4. So I have 6x plus 10 is equal to 4. And then I subtract 10 on both sides. So I have that 6x is equal to negative 6. And then I divide by 6 on both sides. So I have that x is equal to negative 1. And that's it. My answer is x equal to negative 1, y is equal to 2. That means that they meet at the point negative 1, 2. Last example. Now, unfortunately, sometimes when we're asked to solve by elimination, the equations are not always laid out that prettily, I'm not sure if that's a word, for us. So what we have to do is multiply one or both of the equations by a number that will make the equations easy for us to add or subtract. Because what we really want is for one of the two variables to disappear. That's why it's called elimination. So let's see. In this case, we have 2x plus 3y equals 6 and x plus 2y equals 5. Now, as you can see, we can't just add or subtract one of the equations because it will not eliminate one of the variables. So I can do two things. I can either multiply the bottom equation by negative 2 to eliminate the x's, or I can multiply the top by 2 or negative 2 and the bottom by 3 or negative 3 to eliminate the y's. I'm going to do both so you can see it both ways, and then you can choose whatever works for you. Let's first multiply the bottom equation by negative 2. So if I do that, again, I'm going to put this in parentheses, the entire thing, so that I can remember that the entire thing is going to be multiplied by negative 2. So what I'm going to have now is negative 2x, negative 2 times positive 2y is negative 4y, so minus 4y, and it's going to be equal to negative 2 times 5, which is negative 10. And now we have a positive 2x at the top and a negative 2x at the bottom, so those two can be eliminated. So I'm just going to add the bottom equation to the top equation. 2x minus 2x is 0. 3y minus 4y is negative 1y, or just negative y, and then equals to 6 minus 10 is going to be equal to negative 4. Now, this is negative y equals to negative 4. I don't want to know what negative y is. I want to know what y is. So I'm going to have to multiply or divide, whichever you prefer, by negative 1. So then y is actually going to be equal to 4. Now, how do I solve for x? Well, again, I'm just going to substitute the y equals to 4 back into any of the original equations. I can actually substitute it in any of the three. I personally prefer the second one because it's easier. The smaller numbers that you can work with, the better. So x plus 2 times 4 equal to 5. 2 times 4 is 8, so we have x plus 8 is equal to 5. Now I subtract 8 on both sides, so I have x is equal to -3. So the answer to the system of equations is x equals to -3 and y equals to 4, which means that they meet at the point -3, 4. Now let's try it with one of the other two versions that I mentioned earlier. As I mentioned, the other thing I can do is multiply the top by 2 and the bottom by -3. So I'm going to do exactly that. So I can just rewrite this as 4x plus 6y is equal to 12. And the bottom one, I'm going to rewrite it as -3x minus 6y is equal to -15. Why do I do that? Because now in this case, I'm going to be eliminating the y instead of the x. So when that happens, I have 4x minus 3x, which is just x, and then 6y minus 6y, which is 0, and then 2 minus 15 is going to be equal to -3. So x is just going to be equal to -3. I go ahead and substitute the x back into any of the equations. I'm just going to do it over here. So -3 plus 2y is going to be equal to 5. And add 3 on both sides. 2y is going to be equal to 8. And y is equal to 4 when I divide both sides by 2. And that's it. Again, we get the same answer that x is equal to -3 and y is going to be equal to 4. So just choose whichever substitution works best for you. There's not really just one way to do it. You always choose the best way that works for you. Thank you so much for watching. If you would like to do some more practice on your own, I left you a few worksheets on the video description. If this video was helpful, tell me in the comments and make sure to give it a thumbs up. And by the way, don't forget to subscribe so you can find more videos like this one when I post them. I'll see you next time.